Okay. So, acid and bases reaction uh, is very common reaction. It's considered also a realization and neutralization reaction. So, we will practice with some example about these type of reaction. First of all, we will practice how to figure out the Pronoun acid and bases. In general, what do we have? We have, for example, chemical B plus HA. They will react to give HB plus A minus. Which one is acid? Which one is base? Which one conjugate acid? Which one conjugate base? You have to keep in your mind, according to Proust-Lowry definition, the chemical or the species that can donate, give H plus proton, that one will consider acid. And the one that accept H positive will consider base. So that's what you're gonna look for. Which one will give, which one accept the H plus, and you will decide which one is acid, which one base. So here, B, we will compare it before and after the reaction. Compare before and after reaction. B was, go to HB, that's mean accept, so B will be base. HA want to give A, so it's give, donate H, so it will be acid. Now, in the other side, it's also we have acid and base, but we call it conjugate. We call it conjugated acid and conjugated base. So we decide also the same things, but the reverse. You will go opposite. So you will compare HB with B. HB give a proton, so this one will be conjugate acid. A with the HA. So except, so this one will be a conjugate base. And it is confusing also for conjugate acid and conjugate base. It is the opposite to what's happened to the normal acid and base. So here acid will give you base, but we call it conjugate base. The base will give the acid, what we call it conjugate acid. So that's how you will decide acid base, conjugate acid, conjugate base, according to Proust-Lowry definition. Let's look at this two examples quickly here. Let's say HCl plus H2O give us H3O positive plus Cl negative. Which one is acid? Which one is base? Compare HCl with the Cl negative, H2O with the H3O positive. Here, HCl give H positive, give a proton. Don't forget the H positive, we call it the proton. And that will represent the same as hydronium, H3O positive, which is hydronium. It is the same because H positive will react with the water. Always in water, these type reactions. So it will give you H3O positive. Anyway, let's go back here. H to Cl, HCl to Cl negative, so it's good. So this is the acid. H2O except the proton, so H2O here the base. Now the opposite when you will compare H3O positive with H2O, so H3O positive give a proton. As I said, here, when you are working with the conjugate acid and base in the product, you will compare it in the opposite direction. Okay, this type of reaction, you can see there are two directions for the error. That means it's reversible reaction, can go back and forth. We will talk about it in equilibrium chapter. Okay, so H3O positive here will be the conjugate acid, and Cr negative will accept the proton, so it will be the conjugate base. One more example for this definition. Let's say NH3 plus H2O, we will get NH4 positive plus OH negative. Compare NH3 with the NH4, H2O, and OH negative. NH3 accept, so it will be base. H2O, OH minus give the proton, so it will be acid here. NH4 conjugate acid, OH negative conjugate base. Okay, see here some other example. Okay, titration. Let's practice with the titration calculation. When you titrate acid and base, we can do calculation to figure out the concentration of a node. So let's say we have here in this reaction HCl plus NaOH will give us NaCl plus H2O. Look at this equation. How many milliliter we need of 0.1 molar, 0.1 molar NaOH to titrate 250 milliliter or 0.2 molar HCl. Okay, so let's look here. So what do we have? We have how many milliliter we need of 0.1 molar NaOH to titrate 250 milliliter of 0.2 HCl. Don't forget here, molarity equal mole divided by volume in liter. Or sometimes also we can maybe we need this relationship mole equal mass divided by molar mass. Okay, here, what we need? We need mole HCl to mole NaOH, mole to mole ratio. Okay, so here mole to mole ratio. We need to reach here. This one can reach it from molarity times the volume for HCl. That times the volume in liter, we will get the mole of HCl. Then we will use the mole-to-mole ratio to calculate the mole of the neuron. Here they are asking for volume, milliliter. So here, volume, molecular what? Molecular mole, which you will get it here, divided by molality, which you already have it here. Okay, let's do it here. Volume, molarity HCl is 0.2 molar HCl times volume HCl in liter will be 0.25 liter. Now the mole-to-mole ratio between NaOH and HCl, don't forget this is mole. The molarity, it is mole divided by liter, cancel liter with liter. Here, mole-to-mole ratio between HCl and NaOH, it is 1 to 1. 1 more HCl, 1 more NaOH, plus a mole HCl with mole HCl. Now I have a mole of NaOH here in the top, so you will divide it by mole. Sorry, this is mole divided by molarity to get the volume. This is the molarity of NaOH, so it will be 0.1 mole divided by liter NaOH. Get some mole NaOH with this one and do the math. And here we will get 0.2 times 0.25 and divided by 0.01, we will get 0.5. Sorry, 0.2, 5, 0.1, 0.5. So you will get 0.5 liter. So be careful, guys. This is 0.5 liter. They are asking for milliliter, so it will be 500 milliliter. So we need 500 milliliter to titrate the HCl. Okay, let's practice with another example for titration. Okay, now